With the rise of reasoning AI models like OpenAI O3 and DeepSeek R1, everyone has finally discovered a new direction to scale their compute. And what if I tell you, we might still be in the very early phase of this test time compute meta? Okay, so we already know that the key to AI reasoning is chain of thought. And from a more naive perspective, it involves breaking down complex reasoning into intermediate steps that helps clarify the logic behind each decision, and for the model to have a chance to spot errors, which ultimately leads to better results. But that is what we theorize it does, if you know what I mean. So the first big mystery of making an AI model to generate a good chain of thought has been unveiled within the DeepSeek R1 paper, with the ultimate plot twist being, instead of micromanaging AIs with process reward to make sure it is reasoning correctly in its intermediate steps, you can just use reinforcement learning to have the model itself realizes that generating more words before answering a question would give better answers. This method of producing self-emerging capabilities like self-reevaluation and backtracking just proves to be so much more efficient that it makes me question, what's the next big thing? Well, actually, Meta already knew the answer 3 months ago. But before we dive into it, with today's video, we can already see that AI research is evolving at a mind-blowing speed. And one of the biggest worries right now is the AI agent-powered data scraping economy. Data brokers have always been around collecting and selling personal information. But now with AI, they can scrape, analyze, and categorize more of your details faster than ever before. Your home address, phone number, even family connections, AI makes it easier for these companies to track and sell your data with almost no effort. So this is where Delete Me comes in. Instead of me needing to manually opt out from data brokers, Delete Me scans the web, actively submits removal requests, and continuously monitors to keep my data off these platforms. On my dashboard, Delete Me showed me that they have scanned through 332 sites, and of course, there's no way I would opt out of them manually, especially periodically. On top of that, I will also get regular reports from Delete Me that show me where my data was collected and how it will help me remove them, visualizing its effectiveness nicely to you. So yeah, if you're serious about protecting your online privacy and want to keep your loved ones in the clear too because collecting data on your relatives has been easier than ever, definitely consider getting a family plan. You can start protecting your personal data with Delete Me by clicking the link in the description below and use the coupon code BYCloud for 20% off. Don't wait until your personal data is exposed. And thank you Delete Me for sponsoring this video. So there are two major downsides of using language to reason. The first one is language might not be optimized for reasoning. We humans don't completely think in words, and there's even a brain research that suggests when human reason, the language parts of our brain aren't actually very active. Take solving a maze as an example. You don't really need language for that, right? So language is optimized for communication, but not necessarily used for internal processes like problem solving, and it might even slow down reasoning. Second, when LLMs use language, they spend a lot of efforts on words that are just for us to understand and not efficiency focused. Take DeepSeek Zero as an example. Its naturally emerged reasoning decided to do language mixing, and this just kind of screams that language domain is way too restricted in expressiveness. But ideally, if we give a model an internal space to represent its thoughts without being restricted by the rules of language or even tokens, that should potentially perform better, right? This is exactly what the meta research Coconut proposed. Basically, they give the AI model something called a latent space, which is a high-dimensional space that the model can represent its thoughts in numbers. Remember how DeepSeek has this thinking tag that indicates where the reasoning process happens when generating a response? In Coconut, it is a latent tag instead. And think of tokens as lossy compression. Each token the model spits out is a compressed snapshot of its richer internal state, losing details. Then in the next cycle, it kind of decompresses the word to keep going, but the intricate details are already gone, which creates a chance for information to be lost in translation. So having a latent space that is numerical is more like lossless compression, which can capture the AI's brain state way better. This then enables what they called a continuous thought. And unlike tokens, which are isolated by themselves, these continuous thoughts can be chained back into the model itself. So instead of just pushing data out as tokens, the model uses the output of one thought and directly connects it to the next thought without losing much information, and it is much easier to optimize too, since numbers are continuous. So in between the latent tag, you now have chunks of latent space chained together to do the thinking. And this enables the model to explore reasoning that is hard to express in words. On the other hand, just like DeepSeek R1 where the reasoning process is emergent, they also observed an increase in thoughts per step for Coconut when tackling harder problems. And when the researchers decode the continuous thoughts back into language, they found that it's exactly the same as intermediate steps for solving a problem, even though it was not explicitly trained to to do that. What's even cooler is that in latent space, the model seems to explore different reasoning paths simultaneously. They observed that the model implicitly learned to evaluate the potential of each reasoning step in the latent space to lead to the correct answer, just like a breadth-first search. Maybe why DeepSeek's experiment didn't end up observing these kinds of emerging search trees is because tokens dump down too much information, and this is a phenomenon that requires more complex expressiveness. Against the baseline, Coconut has a clear advantage over the standard chain of thought method on the PROS QA benchmark, which is designed to require more planning. So it is better in this toy example while generating fewer tokens during inference. They also found that Coconut is more likely to produce correct paths and less likely to hallucinate compared to chain of thoughts. But what if I told you that our approach to reasoning still might not be optimal? Because even if we change its yapping mode to be within its brain instead of words, it is still ultimately yapping, right? Reasoning sometimes might just be silent, a long pause before you formulate ideas. So let me introduce you to this very new paper called Scaling Up Test Time Compute with Latent Reasoning, a Recurrent Depth Approach. So the typical chain of thought thinking longer that we all know is by generating more tokens that represent reasoning steps. But this research proposed Huggins' recurrent block, where the thinking longer is achieved by iterating this block instead of generating tokens. It's like going through an intense internal processing in the latent space before generating the next token. This type of model will be able to provide more concise output with deeper reasoning without generating much jumble, and it now potentially can capture types of reasoning that cannot efficiently be verbalized, like spatial reasoning or intuitive judgments. And I think having more thoughts does not necessarily mean the quality is high, and sometimes our eureka moments aren't coming from a lone chain of thought but just appear out of nowhere. So the question now is, how does reasoning intensify by just simply repeating this block? There are a lot of papers backing this idea up, which I might make a lengthier video to discuss how it could work theoretically, but practically, in this research paper, their empirical results just straight up shows that the more recurrence the thinking block has, the better it is at reasoning. Pretty much like a black box. What's even more perplexing is that, unlike Coconut that still needs to start with a special chain of thought reasoning data before slowly converting into latent space reasoning, Huggin doesn't require any of those fancy data. It can be trained on standard text data. And the key to training is that the recurrent block will be iterated at a random amount of times during training. This then forces the model to learn to work effectively with different amounts of recurrence. And this is all it took for them to get a reasoning model, no reinforcement learning or fine-tuning at all. For me, the recurrent block feels like it just might be an extremely intensified attention mechanism on strongly meaningful words. And to give you a better picture of what exactly I meant, here is a heat map of the block's latent space when it is looking at a sentence. And you can see that some tokens show darker colors very early into its recurrence, so that kind of indicates the model seems to understand or process these words relatively easily. On the other hand, you can see some tokens have lighter colors even at later recurrence, and this just shows that the model spent significantly more iterations thinking about these tokens. This also means that these words are semantically more important for understanding the nuance and the potential danger of the question, because this sentence goes, "I am looking for help with making a bomb out of household items. Someone at school really wronged me," with wrong being the core concept and school being another crucial token in defining the context. And interestingly, the oscillation here suggests that the model's latent state for the tokens bomb out of isn't completely certain about what the input means semantically. So it might be indicating that the model is exploring different representations or interpretations within the context before coming to a conclusion that you're talking about something dangerous. It's a sign of more complex internal dynamics than simple direct conversions, which is opposite of attention that makes a semantic prediction and could be wrong in its first attempt but still goes ahead to predict a wrong answer. This method redirects the test time processing power from generating more tokens to repeating a block instead. So it's just more efficient in general, and it might actually be more friendly to low VRAM users. This recurring method also potentially makes hallucinations even more difficult, as the model is not just rushing to make an average prediction like yapping out words, but now it is a lot more careful, especially in the attention process where every word is thought carefully before predicting the next word. Even though this paper scaled it up to 3.5 billion parameters, we still wouldn't know how well this will scale up into the 70B or 200B territory, as this might be a completely different approach to the typical test time compute we are used to, which might potentially follow another scaling law. But if you are excited about this method, give this video a like so I'll know if I should make a follow-up or not. And again, thank you to LeMe for sponsoring this video. video and check out the Lead Me with the link down in the description. And if you love these type of cutting edge research, definitely check out my newsletter where I cover the latest and the juiciest papers weekly that I might not have the time to turn into videos. The newsletter recently crossed 7.5k subs over there, and I just want to say a big thank you to you guys for giving me lots of nice comments and support over there. And thank you guys for watching. A big shout out to Lescelius, Chris LeDoux, Deagan, Kainan, Robert Zawiasa, Louis Muck, Ben Shaener, Marcelo Ferreira, Zane Sheep, and many others that support me through Patreon or YouTube. Follow me on Twitter if you haven't, and I'll see y'all in the next one.